Okay, let's jump right into this explainer. Today, we're exploring how a totally groundbreaking architecture is finally solving the single biggest fatal flaw in modern artificial intelligence. Look, we've all seen the incredible, mind-blowing things large language models can do, right? But we also know their darkest secret. They just make things up. So today, we're going to look at how we're actually fixing that once and for all. So, here's the crucial point. When traditional large language models lack information in their static training data, they don't just politely say, "I don't know." Nope. Instead, they hallucinate. They use these complex statistical algorithms to just predict an answer, essentially inventing entirely incorrect facts that sound incredibly plausible. And the worst part? They deliver those fake facts to you with absolute, terrifying confidence. Now, you might be wondering, why does this matter so much? Well, it's because we aren't just using AI to write funny little poems anymore. In high-stakes fields like medical diagnostics, customer service, or legal advisory systems, an AI making up a fake legal precedent or hallucinating a medical symptom, that could be absolutely catastrophic. We desperately need these systems to be grounded in absolute, verifiable reality. To understand how we're fixing this, we're going to break it all down step by step, taking you on the hero's journey of a technology called Retrieval-Augmented Generation. We'll cover the hallucination problem, meet the solution, compare it to fine-tuning, tackle the lost in the middle hurdle, fix the pipeline, and then look at the future of retrieval. Section 1. The AI Hallucination Problem, Frozen in Time. Section 2. Meet RAG, the solution. To really set the stage here, remember that models like GPT-3 and BERT rely entirely on internal static knowledge. They are literally frozen in time the exact moment their training stops. So, without continuous access to new data, they just stagnate. But enter our hero. Around 2020, a hybrid architecture was introduced that dynamically connects language models to the real world. Simply put, Retrieval-Augmented Generation, or RAG, forces the AI to actually look up facts in a reliable external database before it even attempts to speak. It perfectly bridges the gap between the smooth, generative fluency of an AI and the rock-solid factual accuracy of a search engine. It's fascinating how clearly the workload is separated in this system. Your input goes first to a retriever. This retriever uses traditional keyword matching or deep semantic understanding to hunt down the exact right data. Then it hands those ranked facts straight over to a generator. The generator's job is to synthesize all those retrieved documents into a coherent, contextually relevant response. It's brilliant, really. IBM has this fantastic way of illustrating this concept. Think of a standard LLM, like asking an amateur home cook to guess a super complex recipe entirely from memory. You know, they have the basics down, sure, but they totally lack the expert knowledge. On the flip side, the RAG model is that exact same home cook, but you've just handed them a highly specific expert cookbook for that exact cuisine. You're giving them the precise context they need right in the moment, so they really can't mess it up. Section 3. RAG versus fine-tuning. Now, you might be asking yourself, wait, couldn't we just retrain the AI on new data instead of handing it a cookbook? Well, retraining the model, which the industry calls fine-tuning, is kind of like sending that home cook away to culinary school. Yes, it absolutely deepens their domain expertise, but it is computationally massive, wildly expensive, and honestly, it doesn't even fully cure the hallucinations. Plus, the very second they graduate, their knowledge is frozen all over again. RAG, on the other hand, just gives them the cookbook. It's highly cost-effective, provides immediate factual grounding, and it is ridiculously easy to update. If the facts change, you literally just swap out the cookbook. Zero retraining required. It's a total game changer. Section 4. Lost in the middle. But of course, our hero faces a bit of a mid-journey complication here. You see, modern large language models now support these absolutely massive context windows, sometimes extending to millions of tokens. But what happens when the cookbook is 1,000,000 pages long? What happens when we feed an AI dozens of retrieved documents to read before it even answers? Well, we hit a pretty massive context window problem. Researchers discovered this fascinating but frustrating phenomenon called lost in the middle. Basically, LLMs exhibit this U-shaped performance curve. Their performance actually drops by over 30% if the critical information happens to be placed right in the middle of their context window. It all comes down to how their attention mechanisms, specifically things like rope long-term decay, are engineered. They just naturally focus heavily on the very beginning and the very end of a text. This means the absolute best piece of retrieved evidence could be completely, 100% ignored by the model if it just so happens to land in the middle of the prompt. Crazy, right? Section 5. fixing the RAG pipeline. So how do we fix this? Let's look at the advanced engineering counterattack designed to save the RAG pipeline. Engineers quickly realized they couldn't just blindly throw data at the AI, so they came up with a brilliant 1-2 punch. Step 1 is a broad vector search. This uses a hybrid approach of semantic search and traditional BM25 keyword matching to cast a wide net, grabbing anywhere from 20 to 100 candidate documents. Then, step 2 is where the real magic happens, Cross-Encoder Reranking. They bring in a highly precise model to jointly encode both the user query and those documents. This assigns highly refined relevance scores to re-rank and surface only the absolute most important pieces of information. Doing this can actually boost retrieval accuracy by 15 to 30%. But wait, they didn't stop there. To actively fight that U-shaped memory curve, they started using something called optimal document positioning. Once those documents are beautifully re-ranked, engineers strategically place the absolute top-ranked evidence at the very edges of the context window, right at the start and right at the end. They're literally leveraging the AI's natural attention biases instead of fighting against them. They also use contextual chunking. This prepends chunks of data with document-level context, so those little snippets of text don't lose their original meaning. And if we look at the model architecture itself, innovations like multi-scale positional encoding are being used to adjust the attention heads to preserve short and long-range dependencies. That single tweak can improve middle position accuracy by up to 40% without adding any extra computational overhead. Talk about a real game changer. Section 6, the future of retrieval. So where is all this incredible technology evolving next, especially as we start moving way beyond simple text documents? Well, the horizon of RAG is completely multimodal. We aren't just retrieving text anymore. Models are now using sophisticated embeddings like Wave2Vec 2.0 for audio, advanced architectures like Timesformer for video, and incredibly powerful frameworks like Flamingo to retrieve across audio, video, and text simultaneously. Just imagine an AI that can watch a video, listen to speech, and read an article all at the exact same time to generate an incredibly rich, perfectly context-aware answer for you. It's like something out of sci-fi. We're currently seeing an absolute explosion of new agents coming out of recent research. We have things like Self-RAG, which uses reflection tokens to actually evaluate and critique its own retrieved passages dynamically on the fly. Then there's Community KG RAG, exploring complex multi-hop connections in knowledge graphs for some seriously advanced fact-checking. And Raptor, which creates this amazing hierarchical summary tree to retrieve info at varying levels of abstraction for really deep reasoning. This system is basically becoming entirely self-aware of what it already knows and what it specifically needs to go look up. All of this leaves us with a truly fascinating thought to take away. Think about it. If an AI can perfectly retrieve, perfectly re-rank, and perfectly reason over literally any piece of human knowledge instantly from an external database, are we ever going to need to painfully train an AI to memorize facts again? Or is the age of static, hallucinating models officially over, finally making way for the ultimate flawless search engine? I'll let you ponder that one. Thank you so much for joining me on this explainer, and as always, keep questioning the data.